aerodynamic efficiency, or power extracted from wind. But this objective should be met by well-satisfying mechanical strength criteria and economical aspects. In this video we will see impact of number of blades, blade shape, blade length, and tower height on wind turbine design. As number of blades on wind turbine increases, aerodynamic efficiency increases, but in a diminishing manner. When we move from 2 blades to 3 blades design, there is an increase in efficiency of 3%. But when we move from 3 blades to 4 blades design, efficiency gain is marginal. As we increase number of blades, cost of the system increases drastically. Along with that, mechanical design of blades also becomes a difficult affair. With more number of blades, blades should be thinner to be aerodynamically efficient. But blades with thinner portion at root may not withstand bending stress induced due to axial wind loads. So generally wind turbines with 3 blades, which can accommodate a thicker root, are used. The next big factor affecting performance of wind turbine is shape and orientation of blade cross-section. A moving machine experiences fluid flow at a different velocity than actual velocity. It is called as relative, or apparent velocity. Apparent velocity of flow is difference between actual flow and blade velocity. If this is the actual flow velocity, a rotating blade will experience an apparent velocity of this at a particular cross-section. A close look at wind turbine blade will reveal that it is having airfoil cross-sections from root to tip. The driving force of wind turbine is lift force generated when wind flows over such airfoils. Lift force will be perpendicular to apparent velocity. Generally, lift force increases with angle of attack. Along with that, undesirable drag force also increases. While tangential component of lift force supports blade rotation, drag force opposes it. So, a wind turbine can give maximum performance when lift-to-drag ratio is maximum. This is called as optimum angle of attack. Airfoil cross-sections are aligned in a way to operate at this optimum angle of attack. Even though flow velocity is uniform along length of the blade, blade velocity increases linearly as we move to tip. So angle and magnitude of relative velocity of wind varies along length of the blade. Apparent velocity becomes more aligned to core direction as we move to tip. So there should be a continuous twist in blade, so that at every airfoil cross-section angle of attack is optimum. Wind condition can change at any time. So it is also possible to rotate wind turbine blades in its own axis, in order to achieve optimum angle of attack with varying wind condition. This is known as pitching of blades. A clever algorithm which uses wind condition and characteristics of wind turbine as input, governs the pitch angle for the maximum power production. Next big factor affecting performance of wind turbine is length of the blade. As we discussed in first video lecture, power extracted by the wind turbine varies according to this equation. So it is clear that a longer blade will favor the power extraction. But with increase in blade length, deflection of blade tip due to axial wind force also increases. So blind increase in length of the blade may lead to dangerous situation of collision of blade and tower. With increase in blade length, tip velocity increases. Noise produced by the turbine is a strong function of tip velocity. So, it is not permissible to increase blade length after a limit. Other factor which goes against long blades is requirement of huge mechanical structures, which leads to heavy investment. Most critical factor of wind turbine design is determination of proper tower height. Power input available for wind turbine varies as cube of wind speed. So a small change in wind speed will have huge effect on power production. A typical wind speed increase from ground level is shown in figure. So, from power extraction point of view, it is desired to have tower height as high as possible. But difficulty in road transportation and structural design problems put a limit on maximum tower heights possible. Hope you got a good introduction to design aspects of wind turbines.